Uh, Good afternoon to all. So we will continue the body plot today. General procedure for constructing body plots. The following steps are generally involved in constructing the body plot for a given g j omega h j omega. So rewrite the sinusoidal transfer function as a product of basic factors in time constant form. Then identify the corner frequencies associated with each one of these basic factors. Knowing the corner frequency, draw the asymptotic magnitude plot. This plot consists of a straight line segment with a line slope changing at each corner frequency by plus 20 dB per decade for a 0 and minus 20 dB per decade for a pole. So you should understand that every corner frequency there is a change. So here you should think that you should understand that for a 0 the slope will be plus 20 dB. That means the slope is increasing in positive directions, or minus 20 dB per decade for the pole. Pole means it will come down. Okay. Now this will be if multiple poles or multiple zeros are there, then you have to multiply by n with 20. Okay. For a complex conjugate zero or pole, the slope changes by for a 0 it is plus 40 and a pole it is minus 40 dB per decade. Complex conjugate poles. Now from the error graph, determine the correction of the applied to the asymptotic plot. We already found that for our how the error is calculated and how it can be incorporated. Okay. Draw the smooth curve through the connected points and such that it's asymptotic to the line segment. So you already first draw the asymptote. You just consider the errors. You do the corrections. Put the proper points. Then join these points by a smooth curve. Calculate the total phase angle of g, j omega, h omega at different frequencies and plot the resultant phase plot. So this is the procedure. So this you can understand when you are considering a problem. So there it is very clear how it can be done. Now we will take an example. So draw the plot for the transfer function g of s into h of s is equal to 54 into s plus 4, s into s plus 1, s square plus 1.8 s plus 36. Now, before going to this, before we are going to, yes. So what first, the given transfer functions, the given transfer function is a pole zero form, converting it into time constant form. So now if you have to do it in a time constant form, how it can be means, so here what is the constant term that you have to divide it. So for example here x plus 4 you divide by 4, so you will get a 1 plus s by 4, and 4 you have to take it outside, like this is 54 into 4 into 1 plus s by 4. Here s into s plus 1, but here what happened, you have to divide it by 36. When you are dividing it 36, you have to take 36 outside, so you will get s square by 36, then 1.8 s by 36, then 1. So this is the time constant form. Now here 54 into 4, here 36, when you are properly cancelling it, you will get a 6 into 1 plus s by 4, s into s plus 1, then 36 already taken, then 1 plus, now 1.8 by 36 you can make it as 0.3 by 6. So 0.3 into s by 6. Now s square by 36 you can put it as s by 6 all square. Now therefore the sinusoidal transfer function in time constant form is given by, now we have to convert s into j omega. Gj omega into hj omega is equal to 6 into 1 plus j omega by 4, j omega into 1 plus j omega into 1 plus j 0.3 omega by 6 minus omega by 6 all square. So here j omega square will come. So j square means minus, that is why here you are getting a minus. Now this is the transfer function. Here you have to see the base factors we explained in the last class. Now the factors, one you can take it as 6 by j omega, 6 by j omega. Another is 1 plus j omega by 4, 1 plus j omega by 4. Another is 1 divided by 1 plus j omega, 1 divided by 1 plus j omega. Another is 1 plus this quadratic equation, 1 plus j 0.3 into omega by 6 minus omega by 6 all square. That you have to keep it here. That you have to keep it here. Now, when you are observing it, here only you can see the, Now, the corner frequency, 6 by j omega, none. 1 divided by 1 plus omega, omega 1 is equal to 1. Okay, omega 1 is equal to 1. 1 plus j omega by 4, that means here corner frequency is obtained by whatever the term in the j term, that is, here it is j omega, that means imaginary part, that you equate it to 0, then what you are getting? So here omega equated to, yes, the corner frequency is obtained by the previous case, just 1 minute. The corner frequency is obtained by, the corner frequency omega c is equal to 1 by t. You have to consider that. That is the corner frequency. So, or t is equal to 1 by omega. T is equal to 1 by omega. So, the corner frequency is t is equal to 1 by omega. Here, there is t is equal to 1 by omega. So here t is equal to 1 by omega. So here you are getting omega 1 is equal to 1. T is equal to 1 by omega. That is equal to, then you are getting it as omega 2 is equal to 4. So whatever this omega 4, 1 divided by 1 by omega 4. Okay. Or more easily, I will explain how to find the corner frequency. Wait 1 minute. Directly, when you are observing it, you will get it. From the directly, you will get it from here also. What is, a constant, for constant none, s plus 4, whatever the constant term come with S, that is also a corner frequency. From that also you can consider this. So this 4 is a corner frequency. Here S plus 1, there 1 is a corner frequency. Then here 36, that is in the form of square, so 6 is a corner frequency. Or here 6 by j omega, from this we got it. From that omega 1 is equal to 1. Here yes, omega 2 is equal to 4. Now what the term comes below the omega, that you can consider it as the corner frequency. So here both are omega 3 is equal to 6. So later we will understand that. I'll explain more detail in that. Now when you are having a term like this, we already studied that when you are having 6 by j omega, it is having a straight line with a slope of minus 20 dB per decade passing through the it is like, you can see here, it is like this one. It is like this. Here in our case 6 by j omega, 6 by j omega, r is 1. Now this you can see that when omega, log omega, in that omega is equal to 1, that time the value of the graph is 20 log k, that is 20 log, here 6, k is equal to 6. Slope is minus 20 into r is 1, so you are getting minus 20 only. So that you can see here in 6 by j omega, the corner frequency is none. The straight line with a slope of minus. So in order to see that whether there is a corner frequency or not, you can examine here. In this case also, there is no change in the graph. It is going in the same form. That is why there is no corner frequency in this case. For 1 by j omega as well as for k also, it is a straight line. There is no change in the graph. But when you are coming here also there is no change in the graph. But when you are coming to, in this case, you can see that the graph is coming 0 for some time, and after that it is tilted with the minus 20. So there is a change in the plot. There is a graph. The corner frequency exists only for the terms like 1 divided by 1 plus j omega t or 1 plus j omega t, like that. Now in this case 1 divided by 1 plus j omega t is the common form. There the corner frequency is 1 by t. Okay, so that is the way of obtaining the corner frequency. So 1 divided by 1 plus j omega t, where the corner frequency omega c is equal to 1 by t. Only such a type of term, 1 divided by 1 plus j omega t, there is a change in the graph. There only corner frequency exists. In this case also, omega c is equal to 1 by t. Here also, in all terms like 1 plus j omega t, 1 plus j omega t raised to n, in that case only there is a change in the graph and there is a corner frequency. Otherwise, if it is 1 by simple j omega t without any plus term, plus 1 plus, in that case there is no change in the graph, so there won't be any corner frequency. Like in this case, it is a single line. There is no change. There is no deviation in the flow. But when you are coming here initially it was 0, then after that there is a tilt, so there is a corner frequency. Now this is the formula for finding the corner frequency. Now first, when you are taking, there is no corner frequency. When you are taking this 1 divided by 1 plus j omega, so here T is 1. Okay. T is 1. T is 1. So omega C or omega 1 is equal to 1 by 1 is equal to 1. So that is why you are getting here at as omega 1 is equal to 1. Now when you are taking this one, 1 plus j omega by 4. Now it is in the form of 1 plus j omega t, and omega c is equal to 1 by t. Here when you are observing, comparing these two expressions, here t is equal to 1 by 4. So omega 2 is equal to 1 divided by 1 by 4. You are getting it as 4. So that is why you are getting here corner frequency. Similarly here also it is in the form of omega t. So omega c is 1 by t. So that is why you are getting here. Now when you are having S6 by j omega, the straight line with a slope of minus 20 by decade passing through the value of 20 log k. That means 20 log k. K is 6. So 20 log 6 is equal to 15.56 dB. Point at omega is equal to 1. So for that, again the phase angle you have to see, you have to study thoroughly individual factors. Now here this is our form of base factor k divided by j omega raised to r, where r is equal to 1. R is equal to 1. In that case you are getting a slope, and at omega 1 the value of this graph is 20 log 6. That is, that value you are getting it. And moreover, the angle for this type of graph is minus 90 degrees. So that you have to incorporate here. So you are getting here it as minus 90 degree. Now next one is 1 divided by 1 plus j omega. That means a pole, and there is a 1 plus 1 plus j omega. Now omega 1 is 1. Till 1 it is 0. After that you can see that after that till omega 1 is 1, that time the graph is 0. After that, because it is a pole equations denominator term, so it is having minus 20 dB per. After, when omega greater than omega 1, it is a straight line with a slope of minus 20 dB per decade. So when omega less than omega 1 till 1 or omega less than 1, it is a straight line of 0 dB. When omega greater than 1, it is a straight line with a slope of minus 20 dB per decade. Now when you are going to see the corresponding 1 divided by 1 plus j omega t. This is the base factor. Now you can see that the angle is when omega less than, when omega is 0, that time it is 0 degree, and omega is infinity, that time it is minus degree. Omega at corner frequency it is minus 45 degree. So same thing happening here also. Phase angle varies from 0 to 90 degree. At omega is equal to omega 1. This is the corner frequency, that is equal to 1. The angle is minus 45 degree. Now when you are taking this 1 plus j omega by 4, corner frequency is 4 till 4, because it is a 0. There is it is a 0 form. So till 4 it is a straight line of 0 dB, and when omega greater than omega 2, that means 4, it is a straight line with a slope of plus 20 dB. For 0 it is plus 20 dB per decade. Here it is 4 form, it is minus 20 degree. It is a 0 form, it is having plus 20 dB per decade. Again here also at omega omega at corner frequency, you are having plus 45 degree. Yeah. Now we will see this representations. Yeah, this representations, basic diagram. Yeah, this will be 1 plus j omega t. There, yeah, here it is. When it is omega is 0 degree. When at corner frequency it is 45 degree. At this one it is minus 90 degree. So here the phase angle varies from 0 to 90 degree. At omega is equal to omega to 4, pi is equal to not minus 45 degree. It is plus 45 degree. Now the last term, that is 1 divided by 1 plus j 0.3 omega by omega 6 minus omega by omega 6 square. It is having a form of this, that is 1 divided by 1 plus 2 psi omega by omega n minus omega by omega n square. So here omega 3 is equal to 6, corner frequency is 6, and 2 psi is equal to 0.3. So psi is equal to 0.1 pi. So now in this case also, omega less than omega 3 is 6. Again it is a straight line of 0 dB. A straight line of 0 dB. And it is a pole. So it is having a slope of minus 40 dB. You can see that. For omega greater than omega 3 6, it is a straight line with a slope of minus 40 dB per decade. And how the angle varies from, angle varies from 0 and psi is 0.13. So it is almost psi is 0.15. For psi is 0.15, it is coming closer to here. Then suddenly a jump at omega is equal to 1. That time it is minus 90 degree. Then it will go to 0. So you can see the phase angle varies from 0 to minus 180 degree. At omega is equal to omega 3 is equal to 6. Pi is equal to minus 90 degrees. So I request all the students to study the basic factors we analyzed in the last class. So if you study that, it is easy to do it. It is not very tough. You can easily understand this. Now, and the resultant magnitude is drawn. So here, how we have to see that? You have to see the corner frequency starting from the lowest corner frequency, then you have to proceed it. So here the corner frequency, first one is none, then omega 1 is equal to 1, then omega 2 is equal to 4, then omega 3 is equal to 6 like that. So here, now we start with the factor 6 by j omega corresponding to the pole at the origin. So what you can see that, and its magnitude plot, we call it as asymptote 1. So you know that it is having a minus 20 dB per decade, and at omega is equal to 1, the magnitude is 20 dB, 20 log 20 log 6, that is equal to 15.56 dB. So at 1 you are having 15 points. So this is minus 20. So the graph should pass through 15.16 dB. Okay, so what you have to do is, you have to take the semi-log sheet, mark this is 0.1, 1, 10, 100 like that. This side dB. Now you have to start with the minimum corner frequency. the first one graph is known as asymptote 1. You draw the asymptote 1 first. In that we got for omega 1 the the graph value is minus 15.56 minus 15.56 dB. So at 1 you draw a 15.56 on the graph. From there you have to draw a straight line towards the upside and next corner frequency, as you can see that the next corner frequency is omega 1 is 1. So the corner frequency is 1 only. So till 1 at 1 it is 15.56. Till 1 you should draw a minus 20 dB per decade. Minus 20 dB slope, you have to draw a line till 1. So that is the first. Then second term, you have to take the second term. You have to start from this corner. Here omega 1 is equal to 1 means when you are taking this till omega 1 is equal to 1, omega 1 less than 1 is equal to 1, the response is, or a border plot is a straight line at 0 dB. 0 dB. After omega greater than 1, it is a straight line with a slope of minus 20 dB per decade. So here till 1 for a second term, the 0. Now we have to add this 0 plus this term. Because here in a transfer function, you can see that all are this term and all term. You are multiplying this with this, this with this, this with this. Now when you are coming to the logarithmic scale, you have to add it. Now till 1 for the second term, you have to having the 0. 0 with this 0. Then after 1 to next corner frequency, that is till 4, it is having minus 20 dB. And till 1, the previous asymptote 1 is having minus 20 dB. From here onwards, addition of minus 20 dB. So you will get a minus 40 dB till corner frequency. This is 1, 2, 3, 4. Till here, you are having minus 20 plus minus 20. So you are getting a minus 40 dB. Okay. So product term in a normal equation, when you are coming to the logarithm scale, it is addition. So here in the first term is having minus 20 dB. The second term also having minus 20 dB. Then the total effect of the total graph is minus 40 dB from 1 to next corner frequency, that is 4. That is 4. Okay. The angle we will see later. Okay. Okay. Then that you have to draw it. Then third term, that is 1 plus j omega 1. The angle corner frequency is 4. Next corner frequency is 6. So from 4 to 6, before 4 for this term, the straight line with a 0 dB, and after 4, it is a straight line with a slope of plus 20 dB. Now the graph is coming from 1 to 4 with a slope of minus 20 dB. After 4, it is plus 20 dB. So minus 40 plus 20 dB, you will get a 20 dB from 4 to 6. That is around, this is 1, 2, 3, 4, 4 to 6. From here to here, it is minus 20 dB. And before 4, it is 0 will be added, so it won't change. After 4, minus plus 20 dB to minus 40, so you are getting a plus 20 dB. Now, the last term, the amplitude of last term, when you're observing it, you can see that here till corner frequency, it is a straight line of 0 dB. So that 0 will be after 6 or till 6, the effect of fourth term is 0. 0 will be added with the term, it is 0 only. Then, after omega 3 is equal to 6, is a straight line with a slope of minus 40 dB. So here I think that this is 1, this is 2, 3, 4, 1, 2, 3, 4, 5, 6. From here onwards, till here for the fourth term, only fourth term effect is 0. But you are having 3 more terms, that effect is showing this graph. Till 6, that is 0 will be added with the previous, that means previous term only. After 6, the contribution of fourth term is minus 40 dB, and the previous total effect of previous 3 terms is minus 20. So minus 20 plus minus 40, you are getting a 60 dB per decade. So asymptote 4 is with a 60 dB. So this way you have to see the magnitude. Now, when you are calculating the angle pi is angle of 6 into 1 plus j omega 4. Angle 6 angle of, you need to find this. That means for this you consider as K. Yeah, 6 plus. Yeah. So 6 by j omega. The angle is for K, the angle is 0. Now for 1 by j omega, the angle is minus 90. So if you are taking the 6 by j omega, if you are taking one term, 6 is having 0. 1 by j omega is having minus 90 degree. Then we take this denominator, 1 divided by 1 plus j omega. 1 divided by 1 plus j omega gives minus tan inverse of omega, because it is in denominator. So minus tan inverse of the imaginary part divided by the real part. So it is minus tan inverse of omega. For this quadratic equation, it is equal to, again it is denominator, it is even tan inverse of, you can see that the imaginary part, that is 0.3 omega by 6 divided by 1 minus omega 6 square. So real part is, these two are real part. So 1 minus omega 6 by square, that is minus tan inverse, because it is in denominator. Now there is a numerator term, 1 plus j omega by 4. The angle is tan inverse of plus, because it is in numerator. So plus tan inverse of omega by 4. Now you can calculate substituting the value of omega. Omega is 1. When you are substituting the value of omega 1, pi is equal to, when you are substituting all the value, you are getting minus 123.91. When omega is equal to 4, you have to take the corner frequencies. 4, pi is equal to, substituting all the value, you are getting minus 140.8 degree. when omega is equal to 5, omega is equal to 5, you have to calculate it using this expression. Okay, tan inverse of 1 is 45 degree. Using that you can calculate it. Using calculator, omega is 5.5, you are getting minus 176. Like that, for omega is equal to 8. So for starting from omega is equal to 1, the angle is 0 degree to, see, all the angle you calculated, it is in this range minus 123 onwards. So total angle is minus sign, so you have to represent pi from 0 to minus 270, and for different omega value you put the corresponding degree. Okay, now after you are plotting, you are getting the phase plot of the above term is like this.